Hey Madison, I want to make sure that you understand this problem. So what I did here was I drew a graph of the equation y equals 100t minus 16t squared over the interval from 0 to a little bit over 6. And hopefully you can see that this function represents the height of a ball that's thrown up in the air. So the ball when it's thrown up in the air, it reaches a certain height, and then eventually it reaches its maximum height, and then it's going to start falling back to the ground. So then the height starts to approach the ground, which is 0 feet. Now, this question wants us to find the average velocity of the rock over a certain time period. And the average velocity is just basically the average rate of change over a specific time period. And it tells us to take a look at the average velocity for the time period beginning when t equals 0. And then let's take a look at the first one, lasting 0.5 seconds. So if we start at t equals 2, then that means that the point that we're looking at is this point here when t equals 2. And if it lasts 0.5 seconds, then that means we want to know what is the height after 2.5 seconds, right? Because 0.5 seconds after 2 seconds is 2.5 seconds. So that means we're looking at this point up here. And if you take a look at those 2 points and we connect them, you can see that it's positive. It's where the function's increasing. So we expect the average rate of change to be a positive value. Okay, so how do we calculate that average rate of change? Remember, to calculate the average rate of change, I need y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where x here is our t. So for question 1, right, you're looking at calculating the average rate of change between 2.5 minus 2, right? And you divide that in 2. Okay, now I need to figure out what the output value is. So let me call y, let's call this f of x. Okay, so f of x, or actually let me use t here instead of x. Okay, so f of t is equal to 100t minus 16t squared. So we have to evaluate the function. So now I need to ask myself, what is the output value when t or x is 2? What is the output value when t or x is 2.5? Okay, so if you put that into the calculator here, you would evaluate 100 times 2 minus 16 times 2 squared. That's going to give us 136 feet. So at t equals 2, the rock is 136 feet above the air. And then after 2.5 seconds, again, let's put that into the equation. That's 2.5 minus 16 times 2.5 squared. And that's actually 150 feet. So that means that this output value here is 150 feet. And now you have the values to put into the equation. So this is going to be 150 feet after 2.5 seconds, and then 136 feet after 2 seconds. And so if you put that into your calculator and calculate the average rate of change, you'll get 14 over 0.5, which is 28 feet per second. So what this tells us is it tells us that between 2 seconds and 2.5 seconds, the rock is still rising, and it's rising at an average velocity or a rate of 28 feet per second.